Hello everyone. I want to talk about enthalpies of formation. Now enthalpy of formation, or delta H now with the sub F there, is the formation of a compound from its constituent elements. So very simply, enthalpy of formation says if I'm going to make CO2, okay, and there's more definitions that are applied to this, I need to bring that up from its actual parts. The actual parts are carbon and oxygen. Notice oxygen is diatomic. It's very simple like that. Another example of an equation of formation is if I were to make NaCl from its parts, and again the parts are Na plus Cl2, but again if I want to make just 1 mole, which says it down below, I need to use half of this. Okay? Now, so where did I get all that? Let's look a little bit farther. If I look at this equation or definition right here, the standard enthalpy change says the change in the enthalpy when all the reactants are in their standard states. So now you'll notice that carbon has to be a gas because at 1 atmosphere at 298 K or 25 degrees Celsius, that's essentially what's going on in Stowe, Ohio right now, or something very close to it, at least room temperature. Carbon's a gas. Oxygen's a gas, so I would put a gas here. Sodium's a solid because it's a metal. This is a gas, but it's also diatomic. So we have to deal with that too. Okay? So again, we have to consider things in their standard states. That's not STP, by the way. Okay? So, wow, look at that definition. The standard enthalpy of formation, or the delta HF standard, okay? So delta enthalpy of formation in their standard states says that the change in enthalpy for the reaction that forms 1 mole of a compound, so we have to figure 1 mole of a compound, from its substances in their standard states, okay? And there's huge tables that contain this data, okay? But if I'm ever going to write an equation, I have to just create 1 mole of a compound. I believe this slide kind of doubles up on what I just talked about, but don't forget the standard states for a compound is here. The standard states for a compound is 1 atmosphere. We're going to look at the state for a solid or liquid, and again, that's at room temperature, okay? If it's a solution, by the way, look at it, says 1 mole per liter, okay? No matter what it is, it's always 1 mole per liter. And if it's anything for an element, again, we're back to 1 atmosphere and 25 degrees Celsius. And here's an example. The standard state for H2 is a gas, for sodium is a solid, and again, 1 atmosphere, 25 degrees Celsius. So again, essentially what it's at room temperature, okay? So now if we consider nitrogen dioxide, and again, I already did a couple examples, but take a look at this. To make nitrogen dioxide from its parts, you have nitrogen and oxygen. There it is right there. There's nitrogen, there's oxygen. Here are its parts here and here. Notice nitrogen has to be diatomic at room temperature. Oxygen, same thing. They're both gases at room temperature. But to create 1 mole of this, which was part of the definition, you need to use half a mole of N2 to get that balanced. Okay, so looking a little bit further at another example, here we create water, and you'll notice it's the same thing. Okay, 1 mole of H2 on the left to create 1 mole of water, and then we need a half O2 because again we're creating just 1 mole of water. That means there's only 1 there, so I have to cut that in half. Okay, so again we're just creating things, and again I probably should go back. What are we actually doing? We're standardizing reactions here. We're standardizing reactions. In other words, we're going to control the situation in which we're going to make a reaction happen, and then we're going to figure out the delta H on that, and we'll write that down somewhere. That gives us our delta H of formation of those 1 mole of those products in their standard states. Okay, again, that standard is the standardization that we're doing here. Okay, so we'll get to this one in class. What I want to do though is, okay, here we go. I want to practice a lot of the problems, but what I'm going to do is instead of working out the problems, I'm just going to show you the slide and then show you the answer. And you guys can work it out and pause the videos, okay? I think that'll be helpful. I thought of that just the other day. So if we're going to make carbon tetrachloride, you're going to make 1 mole, done, okay, from its parts in standard states. Well, carbon in its standard state in room temperature in 1 atmosphere is a solid. It's like charcoal, okay? It's like a carbon dust, a black dust. Chlorine is Cl2 as a gas, okay, that's its standard states, but I need 2 of them to make 1 mole of that product, okay? So again, that's another example of that. And this is the equation we're going to plug into it. So it's really actually not too bad at all. So this looks very, very complicated. So we're going to use those tables of all those numbers that's listed somewhere and plug them into this equation. Now, if you don't know what that is, that's a sigma, and that stands for sum of. So we're going to take the sum of in 2 cases. So I'm going to add a bunch of things up. What am I going to add up? I'm going to add up the moles of the substances on tables or lists somewhere of the products, add it all up, and I'm going to subtract that from the same thing of the actually products. That should say, whoopsie, that should say reactants. Okay, products minus reactants. Okay, products minus reactants. As a matter of fact, everything we're going to talk about is products minus reactants except for one thing, which is reactants minus products. Okay, but this one's products minus reactants. Okay, so let's go to a practice problem, and I'll show you how not bad at all this is. Okay, so here's an example. Calculate the standard enthalpy change. So the delta H. So we're going to calculate the delta H standard for the combustion of methane, and here's the equation. So what we need, and we'll walk through this one real quick here. Here's our equation here. Okay. So we want to know we want to know what the enthalpy change is for this reaction. Okay. Here's the stuff that's listed on our table. We need every single one of those numbers. You will notice that every compound has a number, except for oxygen. The number 0, I suppose it has a number, the number 0. Anything in its elemental form will have a delta H, a formation of 0, standard of 0. Okay, the delta H standard of formation is 0 for all elements. Okay, that makes life a whole bunch easier. Okay, so don't forget that when you see 0 pop up. Okay, so what we're going to do is we're going to take the sum of all the moles of the delta HF standards of the products minus the same thing for the reactants. So notice we have, let's go to the products. We have 1 mole of CO2, 1 mole of CO2. We should be using one of these. Okay, and they did. Okay, but now we have 2 liquid waters. Here's liquid water, here's 286. We should multiply that by 2, and they did. Okay, in this particular problem. Move this up a little bit. Okay, so I'm going to add these up, and I'm going to subtract that to the same thing to the reactants. So now the reactants are over here. I have 1 mole of methane. It should be 1 mole, one of these at negative 75. There it is. And add that to 2 moles of 0. Well, that's just 0, so you don't even have to count that. So subtract these 2, and you end up with this. Okay? Simple. It's really not bad. It's just adding up what's on tables. So here's another example, okay? I'll move it down so you guys can see the results and practice it if you want. Okay? It says calculate the standard enthalpy change for the thermite reaction. It lists the thermite reaction. They're just asking you for delta H of formation, delta H reaction. Whoops, delta H reaction. Okay, there it is. You're looking for that. There it is, there it is. Okay? Let's try another. Okay. So again, we'll work on a bunch of these in class. Here's the answer. Okay. Same thing. Now you're going to do some calculating. Okay, so we're going to calculate the standard enthalpy of methanol. The answer is A. Same thing. I think we're beating this up. The equation of standard enthalpy is okay. 1 mole of hydrochloric acid. So they want to know hydrochloric acid. Okay. This one's a little different. We'll go over this one in class. Okay. They list it kind of funky here. So anyway, let's just take a look at the answer. C. Okay. What is the standard enthalpy information for aluminum oxide? So now they're giving you, okay, now this one's different. They're giving you the total. This is the delta H standard, okay, of the whole reaction. You know, oh, this is more simple than you think. They don't give you any data, so try to figure this one out. I'll show you the answer, okay? They don't give you any data. I told you how to answer this one. The correct answer is A. See what you can do with that one. Standard enthalpy formation of Al2O3 is negative 16.7. Calculate the enthalpy change for the formation of 12 grams. Okay, so now you're starting with the mass. Okay, so now you got to work a little magic here with mass to moles. That's a hint, and the correct answer is D. It says, why can't you perform this calculation? There it is. Correct answer, C. I think there's one more thing. Okay, I'm good with that. So again, with questions, come to class with questions or email me with questions. More on this